Point 5 continued. The other day we were doing inequalities. Today we are doing compound inequalities. There are two different types of compound inequalities. Similar to our English language that have compound sentences, compound inequalities have certain words that link two inequalities together. The two types we have are and or. If we have an and inequality, that means that the solutions must work for both. Okay? If I have an or inequality, that means that the solution only makes one or the other true. Yep. Or, yes. Yes, we did this back in Algebra 1. It won't be so bad. So when we have an and inequality, on a number line, the solutions are sandwiched between two different endpoints. So all of the solutions are sandwiched on an and in between. If it is an or problem, then the solutions go either one direction or they go in the other direction. They go in opposite directions. And is sandwiched in the middle, or is in opposite directions. Okay? Now the way these usually work, we're going to start with and. If everybody's ready, we're going to jump into and first. And is the tougher of the two, because and can be written in two ways. Either with the word and in the middle, or it can be written as one big inequality with two inequality signs. So that's where we're going to start. So if I have an and, it can either be written as, let's say, x is greater than 3 and x is less than or equal to 5. So that's written with the word in the middle. If I were to put that on a number line, at 3, this says I have an open dot at 3, and it goes to the right. And x is less than or equal to 5 says I have a closed dot at 5, and this goes to the left. So all my solutions are sandwiched between 3 and 5. The interval notation for that starts at the 3 with an open dot, so that's a parenthesis, 3 to 5, and because it's a closed dot, it's a bracket. Very good. So this is one way to write an and problem. An and problem can also be written in an inequality altogether. So it would be written in 3 less than x less than or equal to 5. So when you have these inequality signs and they're written in this form, this is saying if I cover up this part, x is greater than 3, x is less than or equal to 5. They're just written in all one. And the signs always have to go in this direction. This is the only way the signs make sense. Okay? So an and problem can be written both of these ways. Now, if you're solving one that's got the word and in it, that's super easy to do, right? You solve two separate ones and you put it on the same number line. It's when they're written all together it can be a little bit tougher. All right, so let's do our first example. You guys are all excited. Liven up. No? Example number 1. All right, so let's say I have negative 10 is less than 2x plus 4 less than or equal to 20. That looks good. So you can see there's two sets of inequality signs, right? All in one thing. So this is an and problem. The idea is we want to get the x by itself in the middle. Whatever we do to the middle to get x by itself, we have to do to both ends. Okay? So the first thing is if I want to get 2x by itself, I'm going to subtract 4. Well, if I subtract 4 from the middle, I have to subtract 4 from both ends. So negative 10 minus 4 is negative 14, less than 2x, less than or equal to 16. Now, is x by itself yet? Correct. We're going to divide by 2. Whatever I do to the middle, I have to do to both ends. So I have negative 7 less than x, less than or equal to 8. So on a number line, at negative 7, I have an open dot. At 8, because it's less than or equal to, I have a closed dot. And the x's fall in the middle. Okay. So this first one, this sign right here, how it doesn't have a line underneath it, this says x is greater than negative 7. So at negative 7, it's everything that goes that way. If I cover up this piece, that says x is less than or equal to 8. So we have a closed dot for the less than or equal to 8, and it says x is everything that goes this way. Okay? So all the correct answers are sandwiched between those two endpoints. The interval notation for this is that open dot's a parenthesis at negative 7, that closed dot's a bracket at 8. It's anything that falls between there. Questions? Give me some more questions. We're okay? All right, let's try another one then. I'm not going to throw a wrench in it. Nah, I wouldn't do that. I wouldn't do that. Example number 2. Let's go with 37 is greater than 12 plus 5x greater than negative 28. All right, so what kind of problem do we have here? Because x is in the middle of two inequality signs, right? Okay, so then we want to get x by itself. What do you want to do first? Subtract 12. I like that idea. All right, so I have 25 is greater than 5x is greater than negative 40. Okay, is x by itself yet? Divide by 5. I agree. And whatever I do in the middle, I have to do to the two ends. This says 5 is greater than x is greater than negative 8. But look at that inequality. There's something wrong there. Yeah, the signs are facing the wrong way, but look at the endpoints. Aren't they also in the wrong places? Right? Shouldn't negative 8 be on this side and shouldn't 5 be on that side? So this whole thing has to be flipped. Exactly. So this should be negative 8 is less than x less than 5. The signs always have to be going this way for the correct and problem. Huh? Yeah. So I don't know what else I can do to help you remember it, but we're going to try. So on a number line at negative 8, do I have an open or closed dot? It's open because there's no line underneath that inequality, right? Over here at 5, is it open or closed dot? And the x's fall in the middle. It's sandwiched in the middle. Interval notation, an open dot's a parenthesis, negative 8 to 5 is a parenthesis. Questions? Any questions at all? All right, so let's go to OR. OR is the easier one. Let's talk about OR. OR. Remember I said that OR has solutions that go fit one or the other one, right? When we graph an OR problem, they go in opposite directions. So let's talk about that a little bit. If I have, let's say I have x is less than negative 2, or x is greater than or equal to 5. Not yet. I'm talking about OR first. All right. So if I were to graph x is less than negative 2, I'd have a negative 2 here, open dot, x is less than. This is what you guys did the other day, right? That fits that inequality. Sign goes the same direction as the arrow, right? And then if I go over here and do this one, at 5, x is greater than or equal to, so it's a solid dot, and we say x is greater than, so it goes that way, and the arrow, same as the inequality sign. So this is going in opposite directions on the same number line. That's why it's an OR problem. So your solutions are either over here or they're over here. Now the interval notation is where the fun begins, right? If I were to do the interval notation for just this piece, that is negative infinity to negative 2. We did that the other day. If I were to do the interval notation for just this piece, that would be a bracket 5 to infinity. But how do we attach the two together? How do we do that, Ian? A U in the middle. Right? Do you guys remember putting a U between the two pieces? All right. So when we're doing an OR problem, you'll notice there's always two inequalities. There's always two pieces on the graph. And there's always two pieces in the interval notation. All right? OR is always going in opposite ways. All right, so let's try example number 3. If you guys think you got it after example 3, I will stop and get you your worksheet. Sound like a plan? All right, so let's go with, what if I had, how about 5x plus 4 is less than negative 6. Or 2x minus 10 is greater than or equal to 20. All right, so when you're doing an OR, you're just going to solve the first inequality. So we're going to start by solving this one. I have 5x plus 4 is less than negative 6. How do I solve it? I first subtract 4 from both sides. This is what you did the other day. We have 5x is less than negative 10. Now what? Good. Divide by 5. So we get x is less than negative 2. All right. I'm going to go ahead and put that on my number line. At negative 2, I have an open dot, and it goes to the left. It is less than. Now I'm going to go solve my other one. Over here, I'm going to start by adding 10 to both sides. So I have 2x is greater than or equal to 30. Get x by itself. I got to divide both sides by 2. I get x is greater than or equal to 15. So at 15, do I have an open or closed dot? Good. Which direction does this go? The other way. Goes to the right. Very good. Interval notation. Starts at this arrow, the negative infinity to negative 2. It's an open dot, so it's a parenthesis. We put a U in the middle. We start at the bracket for a closed dot, 15 to infinity. Are there any questions? Okay. So you guys that have had me before, right? You know we've done this. You have to do interval notation, all that wonderful stuff. Those of you that haven't,